Hello everybody and welcome to today's lesson on properties of logarithms. And our objective today is we will investigate the properties of logarithms. Now, first of all, what is a logarithm? You're probably asking yourselves. And a logarithm is a specific type of function. And in order to understand what it does, let's consider our equations here in these examples and solve for x. 2 to the power of x is equal to 4. And if we want to find out what x is, we have to ask ourselves which exponent is going to turn 2 to 4. And fortunately, we have an easy answer for that. That is 2 to the power of 2. In other words, x is equal to 2. Let's look at our next example. 2 to the power of x is equal to 8. What exponent does 2 have to be raised to? How many times that has to be multiplied by itself in order to give us 8? And here we also fairly quickly find out that the answer is 3. Now what about the next one? 2 to the power of x is equal to 6. That is a number that we can't so easily find out. We can tell, particularly looking at those previous two examples, that x probably will be somewhere between 2 and 3, but what the number is, we really don't know. And that is where the logarithm comes into play. The logarithm is the function that gives us that number x. And the way we write it is the logarithm of the base 2, we have our base 2 right here, of 6, which is our answer of the previous problem, is equal to x. So further down here, you will see it again. The definition of a logarithm with base b, and y has to be a positive number and b cannot be equal to 1, is the log with base b of y is equal to x if and only if b to the power of x is equal to y. So these are two different but related ways to relate the x to the y. The one here on the left is called the logarithmic form, and the one to the right is called the exponential form. And from the logarithmic to the exponential form, we get, by going kind of in circles, we got log with base b of y is equal to x. And then we go in a circle, b to the power of x is equal to y. And looking at how the x and the y switch places here, in a logarithm, we wanted to find the logarithm of a certain y, and the answer was x. And down here in the exponential form, we get x as the input, as the exponent, which will give us a certain y as the output. We can tell that these two type of functions are actually inverse functions. So keep that in mind, and we'll get back to that later in this unit. Your calculator has two different types of logarithms that you can just freely access from there and get the numbers for it. One is called the common logarithm, and that's the logarithm of the base of 10. And also very often we write that one without even showing the base. It's similar as when with the square root we don't show the index of 2. Every time we see the log sign, we just know that it is the log with the base of 10. And the other very important one is the natural logarithm, and that's the logarithm with a base of e. E, Euler's number, and you learned about that in our last class. And that one usually goes by the abbreviation ln for natural logarithm. We will work with the calculator later, but first of all, we can do a whole bunch of things with logarithms without even using the calculator. And the first thing we're going to do is to rewrite equations in exponential form. Here we have the log with base 4 of 64 is equal to 3. So going in circles, 4 being the base, 3 the exponent, 64 the result. We get 4 cubed is equal to 64. And if we think about it, that is indeed the case. Let's do our next one. 5 cubed is equal to 125. 5 cubed is equal to 125, and that is also what we figured out ourselves. And 7 to the power of 0 is 1. 7, or any number for that matter, to the power of 0 is always 1. That's how we rewrite logarithmic form into exponential form. And we can of course go the other way around as well. We write the following equation in logarithmic form. In example 4, 3 is the base, so the log with base 3 of 81 is equal to 4. In our next example, it's the log with base 2 of 32, which is equal to 5. And in our last example, the log with base 4 of 64 is equal to 3. And guess what? That is exactly the example that we had before backwards. So in words described, what does the log with base 4 of 256 really mean? The log is the exponent needed to turn the number 4 into 256. So the log will give you the exponent. So let's evaluate the following logarithms without a calculator. We can do that for many numbers without even accessing the calculator. What is the exponent needed to turn 3 into 243? And if we just go through the motions, 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243. We can say 3 to the power of 5 is equal to 243. So that is the log with base 3 of 243. What is the number we need to turn 2 into 2? What is that exponent we need? 2 stays itself, so the exponent is 1. What is the number that will turn 5 into 1? And there's one exponent, and that is 0. Let's move to the next one. What exponent will turn 4 into -2? Now that one we need to think about for a minute, right? What number can we use as an exponent to turn any number into a negative number? Remember, even if we're using a negative exponent, all that really does is it takes our base and flips it into the denominator, but the result still stays positive. So there is no number that does that. The log base 4 of -2 does not exist. We cannot take the log of a negative number. That's important. Keep that in mind. And in our last example, what is the log that will take our number 1/3 and turn it into 81? We know that 81 is 3 to the 4th power. We went through that when we looked at our first example here on the left. But how do we get that 3 to get back into the numerator? Yes, again, with a negative exponent, right? So 1/3 to the -4th is the same as 3 to the 4th, and that is 81. So the log with base 1/3 of 81 is -4. Alright, so much for now, and now go ahead and watch the second part of this tutorial where we'll talk about the properties of logarithms.